Hi, and welcome to Geometry with Emma. Today we'll be talking about properties and attributes of a triangle. Before we can start learning about properties of a triangle, we need to know about perpendicular bisectors, angle bisectors, and equidistant points. Equidistant points are the same distance from two or more objects. So for example, in this diagram, C is equidistant to A and B because the segments AC and CB are congruent. A perpendicular bisector is a line that both bisects a line segment and is perpendicular to it. So, for example, in this diagram, this line C is the perpendicular bisector of AB because AC and CB are congruent, and line C is perpendicular to line AB, which we can see because this angle is a right angle. Finally, an angle bisector is a line or array that divides an angle into two equal angles. For example, in this diagram, the ray BD is the bisector of angle ABC, and you can tell this because ABD and DBC are congruent angles. Let's do some example problems about this together. Alright, in this problem, we are given triangle ABD and its perpendicular bisector, CD. We know that CD is the perpendicular bisector of segment AB because angle ACD is a right angle and segments AC and CB are congruent. We also know that segments AD and DB are congruent because a point on a perpendicular bisector, such as point D, is the same distance away from the endpoints of the segment it is a bisector of. For example, point B and point A. Now, all we have to do is create an equation and solve it. And then plug the value of n back into one of the original equations. And we have the length of our segment. Alright, here we have another example problem. In this diagram, you can see that we have angle DEF, and that ray EG is the angle bisector of angle DEF. We can tell this because angle DEG and angle GEF are congruent. Now, we are asked to find the measure of DG. We can find this rather easily using the angle bisector theorem. We know that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Point G is on the bisector of the angle, so therefore it is equidistant to points D and F. Therefore we know that this line is 3.5. We just need to learn one more definition before we can start learning about the properties of triangles, and this is concurrent lines. Concurrent lines are three or more lines that intersect at one point. The point where they meet is called the point of concurrency. So in this example, lines AB, CD, and EF are concurrent, and point G is the point of concurrency. Now we can start learning about the properties of a triangle. First, let's learn about the circumcenter of a triangle. The circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle's sides. Keep in mind that depending on what type of triangle you have, the circumcenter might not be inside the triangle. In a right triangle, it will be on the triangle. In an obtuse triangle, it will be outside of the triangle. And in an acute or equal angular triangle, it will be inside of the triangle. Now, if you draw a circle around a triangle, like this, so that all the vertices of the triangle lie on the circle, you have just circumscribed the triangle. The center of the outer circle is the same as the circumcenter of the triangle. Now, the circumcenter theorem says that the circumcenter a triangle is equidistant from the vertices of the triangle. This example problem shows that the perpendicular bisectors of each side have been drawn in blue. And yes, they're congruent here. And the lines from the circumcenter to the vertices have been drawn in pink. On a test, they would not be drawn in colors, but it's much more helpful to look at the image like this. Now the problem asks to find the lengths of the two lines that are given values. We know that they are congruent lines because the circumcenter of the triangle is equidistant to all the vertices of the triangle. So we can set this up as an equation and solve it. A similar concept to the circumcenter is the incenter of a triangle. This is the point of concurrency of the three angle bisectors of a triangle. The incenter will always be inside of the triangle, as you can see from this diagram and this one. If you draw a circle inside of a triangle like this one, so that each side of the triangle intersects the circle only once, you've just inscribed the triangle. The center of the inscribed circle is the same as the incenter of the triangle. The incenter theorem says that the incenter of a triangle is equidistant from the sides of the triangle. These lines from the incenter to the side of the triangle will all be perpendicular to the side, because the shortest distance from a point to a line is perpendicular to the line, such as this line here. This example problem is asking us to find the length of the line that's marked with question marks. Because of the incenter theorem, we know that all of these lines that are marked in pink are congruent. So we can say that this line has a length of 6 because one of the other lines has a length of 6, and all congruent lines are equal. Now we'll move on to medians and altitudes. A median of a triangle is a segment whose endpoints are the vertex of the triangle and the midpoint of the opposite side. For example, in this diagram, line segment BC has one endpoint that's the vertex of the triangle, and the other endpoint is the midpoint of this side. The centroid theorem tells us that the centroid is located 2/3 of the distance from each vertex of the triangle to the midpoint of the opposite side. So for example, here, if line segment AB had a length of 1, then segment AC would have a length of 2/3, and CB would have a length of 1/3. This problem tells us that DC has a length of 6, and asks us what the length of DF is. Well, it's very simple to find out. We know that 2/3 of DF is equal to 6. We just need to solve this equation for DF. First, multiply the entire equation by 3 to get rid of the fraction, which gives you 2DF equals 18. Then divide both sides by 2, and you get that DF is equal to 9. Alright, now we're going to learn about the altitude of a triangle. An altitude of a triangle is a perpendicular segment from a vertex of a triangle to the line containing the opposite side. For example, here you can see that this line has as one of its endpoints the vertex of the triangle and is perpendicular to the opposite side. Depending on the type of triangle, the altitude's endpoint may not lie on the side of the triangle, but rather the line containing the side of the triangle. For example, as you can see here, the line that is perpendicular to this side and coming from this vertex of the triangle does not meet the side of the triangle, but rather the line containing it, out here. The point of concurrency of the altitudes of the triangle is called the orthocenter, and this point does not have to be inside the triangle. For example, in this diagram, it's all the way over here. The last thing that we're going to learn about today is the midsegments of a triangle. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So as you can see in this diagram, segment XY joins the midpoints of segment AB and segment AC. A triangle has 3 midsegments, and together they form the midsegment triangle. According to the triangle midsegment theorem, a midsegment is parallel to a side of the triangle, and its length is half the length of that side. As you can see, this side that a midsegment is parallel to is the side whose midpoint is not included in the midsegment. Let's use the properties of triangle midsegments to solve some example problems. In this problem, we are given values for 2 segments. This midsegment is 3x, and this side of the triangle is 4x plus 4. We know that this is the side not included in the midsegment. Therefore, the midsegment is half the length of the full side. We can use this to write an equation and solve it. So we would set up our equation like this, and then multiply 4x plus 4 by 1/2. Then subtract 2x from both sides, and you get 2 equals x. Then you plug it back in, and you get that 3 times 2 is 6, and 4 times 2 plus 4 is 12. Now in this problem, you are given that the measure of angle DBC is 43 degrees, and you must figure out the measure of angle BAE, or this angle right here. Now, you know that segment BD and segment AE are parallel by the triangle midsegment theorem. And if you extend these parallel lines and the other side of the triangle, you see that segment AC is a transversal to segment DB and segment AE. And when you have 2 parallel lines and a transversal, you know that the corresponding angles are congruent. Angles DBC and BAE are corresponding angles, so you know that they are congruent. Therefore, the measure of angle BAE is 43 degrees. Thanks for watching. I hope you learned something new by watching this video.